Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to sketch a special conic section called hyperbola. And we're going to find the center, foci, vertices, and eccentricity of the hyperbola together with the asymptotes, because hyperbolas have asymptotes, so we also have to find them exactly what they are. And at this moment, let me just remind you the standard equation of a hyperbola. As you see, you have two different kinds. In one case, transverse axis is horizontal. In the other case, it is vertical. And in both cases, the center comes with the coordinates h and k. We have a and b, and as well. A here, in fact, has a special meaning that tells you the distance from the vertices to the center. And there's C, which is not directly involved in the equations of the hyperbola, but C is telling you how far each foci is how far is each foci from the center of the hyperbola. And there's a relationship between A, B, and C. So C squared equals A squared plus B squared. And as I mentioned, we also have asymptotes, and I'm going to talk about that a little bit before I get started. You're going to see all of these tables in the video, but you can see that the asymptotes, depending on the transverse axis, whether it's horizontal or vertical, they are written in terms of the coordinates of the center, h and k, and also b and a. So for us, to write these equations, we have to have the knowledge of the center and also A and B. All right. Also, let me just tell you one more thing. There's something called eccentricity. Eccentricity is referred to E, and E is found by the ratio of C and A. So we're going to also find the eccentricity of each hyperbola. All right, so this was a long intro. I'm sorry, but we have three different tables for you to watch out within the video. So let's get started. All right, let's start with part A. We're given the equation of a hyperbola, y plus 3 quantity squared plus 225 minus x minus 5 quantity squared divided by 64 equals 1. Well, one quick observation is that this equation is very similar to an equation of an ellipse. If I switch this back to plus sign, obviously that's the major difference between ellipses and hyperbolas, okay? So that's only the sign difference. Okay, so let's go back and revisit the standard equations of a hyperbola. We have two different kinds. In one case, we have the transverse axis to be horizontal. That's our first case here. And in the second case, we have the transverse axis as vertical. And the difference is that when you have the horizontal transverse axis, x term comes before, then the y term. And once the transverse axis is vertical, y term comes before then the x term, okay? And the vertices are a units far from the center, the foci are c units far from the center, and different from the ellipse case, c squared is the sum of a squared and b squared, because in the ellipse case, that was the difference of a squared and b squared, okay? And hyperbolas also come with asymptotes. I'm going to also come back to this, but depending on the transverse axis, we have two different asymptotes for each case. And these are only determined by HK and BNA. And eccentricity formula is exactly the same as the one for an ellipse. Okay, that's C over A. All right. So let's see what kind of equation we have first. We have the y term coming before the x term. So the positive one is the y term. So essentially this fits the form where the transverse axis is vertical. Okay, so we're going to make sure like we have the hyperbolas placed on a vertical transverse axis. And the good news is that the way the equation is provided to us is allowing to grab HK, A, and B. Okay, so let's try to work that out. So And here is your h, and here is your k. Okay, so h and k are given like this, and so center is the coordinates h and k, 5 and -3, because here y plus 3 is y minus 3. Just keep that in mind. So the k is in fact -3. Okay, so going back here, so we have 5 and -3, and we also have a and b. So the the bigger number is a. Uh, so that's radical 225, and the smaller one is b, radical 64. So this one is 15, and this one is 8, because these guys are a squared and b squared, right? So the square of those are provided to us. So essentially, let me just rewrite down this equation. You have the quantity squared 15 squared minus x minus 5, quantity squared 8 squared equals 1. Okay. We can go ahead and write down the formula for c. C squared equals a squared plus b squared. Okay. So that is 225 plus 64, which is 289. And if you take the square root of that, c is just 17. Okay. All right, we have almost all ingredients, and remember that the transverse axis is vertical. Let me just write that down here. Transverse axis is vertical. So that means the foci and the vertices are going to be lined up in the y direction. Okay. So if the center is 5 and -3, we're going to find a location of or locations of vertices by going 15 units apart from the center in the y direction, up and down. Okay. So here we go. Let me just write down the center here. Well, we have the center, we have the vertices now. Okay, and we're going in y direction, so we're adding 15 and subtracting 15 to get to the y coordinates of the vertices. Okay, so 5, 12, and 5, -18 are the coordinates of vertices. And how about the foci? And foci are a units apart from the center. Okay, again in the y direction. Okay, so let's see, c is 17. Okay, like if I go, like I'm going to add 17 and subtract 17 from this. 5, 14, and 5, -20. Okay, the locations of foci. All right, the eccentricity, as I said, is the same. C over A, right? That's 17 divided by 15. All right, so now I'm going to take you back to the table where we have the asymptotes listed. Okay. So we have a vertical transverse axis. I'm going to grab these two. Okay. Y equals k plus a over b x minus h, and k minus a over b x minus h. So let's go ahead and write down the equations of the asymptotes. Y equals k plus y. Let me just write it first. X minus h. Okay. All right. So in fact, that includes both of them, right? It's plus minus. Okay. So -3. That's our k. The y entry, y coordinate at the center. Okay. Plus minus b over a, so 8 over 15, x minus h, the x coordinate of the center, right? So it's 15. It's just 5, yeah. Okay. So we have two asymptotes. One comes with plus sign, the other one comes with the minus sign. So I think that's all it is in terms of finding the vertices, foci, eccentricity, and asymptotes. So we want to make sure like we got the right output here. And please, at this moment, have your TI-84 and try to plot this equation here. And I want to, well, together with the asymptotes. So we want to make sure like these are really the asymptotes that we're after. Okay, and let's see what it's going to pop in your calculator. And I did one for myself here. We have the blue curve representing the hyperbola, where the axis that is the transverse axis. So we have the transverse axis to be vertical, obviously. So the foci, vertices, in the center are located on that axis. Okay, and as you see that this is the center. And the green and red dots, so greens are the foci, okay, and the red ones are the vertices. And they are very close to each other, okay, they're very close to each other. And you also have the asymptotes, which are the dashed lines here. So one is this one, and the other one is this one, okay. So as you see that hyperbola, both branches go to infinity along the asymptotes, as you see. Okay, and obviously these asymptotes intersect at the center. All right. I think that's all it is for part A, and let's continue to part B in another video to see what I'm going to do for part B. All right. Thanks for watching. Bye.